This video is on the objective, use the law of cosines to solve SSS triangles, right? That's the side, side, side triangles. So triangles in which you know all three side lengths, but you want to know now all three angle measures. And this is the second video on this objective. I'm hoping you've also seen the first one. Alright, and if you'd like to know more about the topic, right, click on More Instruction and look at their notes, their videos, their examples, and hopefully all those help you out. Alright, so I'm going to draw a picture of this, this is a side, side, side triangle, right? I know all three side lengths. Little a is 11, little b is 26, little c is 20. And I want to find the missing angle measures, and they ask us to round to the nearest tenth of a degree. Right. So I'll write that on a piece of paper. Right, so here's the drawing that they're giving us. Again, it's a side, side, side triangle. So in order to solve it, I'll need to apply the law of cosines. Alright, now, as I mentioned in the first video, I prefer finding the largest angle first, because that'll get any obtuse angles out of the way. Right. Now, if you look at all the side lengths, the longest side is B, little b. So that means that angle B is the largest angle. And that's the one I'm going to try to find first then. So I'm going to find angle B, again, using the law of cosines. Now if I'm involving angle B, I'm going to use this version with little b squared equals, a squared plus c squared, minus 2ac times the cosine of angle B. And you've seen me do this in the previous video. If I want to solve for angle B, it means I'm going to want to get this cosine of B alone. I'll do some little algebra here. The cosine of B then would be equal to a squared plus c squared minus b squared, and then all of that divided by 2ac. Because I would add this, subtract b squared, then divide by 2ac. Alright, and then angle B would just be the inverse cosine of that number, of that fraction. So let me do this. Right, so angle B would be the inverse cosine of, and then in the calculator I'm going to put parentheses around my numerator and parentheses around my denominator. So in the numerator I have a squared, 11 squared, plus c squared, right, 20 squared, minus b squared is 26 squared. Right. And then in the denominator I have this product, 2 times a, so 2 times 11, times c, right, times 20. And I'm just going to enter this the way it looks. So I'll pull a calculator up. Make sure you're in degree mode here. They want answers in degrees, it looks like. So mode, I am in degree mode. Alright, so inverse cosine of, and then in parentheses for the numerator, 11 squared, this is 121, plus 20 squared is 400, and then minus, 26 squared, I'll just put 26 squared. And then close parentheses on the numerator, divided by, and then denominator, put parentheses, 2 times 11, that's 22 times 20 would be 440, but let's put 2 times 11 times 20. Close parentheses on the denominator, close parentheses on the inverse cosine, and this angle B is approximately 110 point, to one decimal place, 0.6 degrees. So I'll put that in my drawing. All right, so that's about 110.6 degrees. So now that I've found the largest angle, the other two angles, this is definitely obtuse, right? Bigger than 90. The other two angles have to be acute. So I could find them with, either the law of cosines. I could still use the law of cosines. say I want to find the next largest one, using the law of cosines. The next largest angle would be C, right? C is the next longest side, so angle C is the next largest angle. And I could do the same thing where, the cosine, we know the cosine of angle C would be a squared plus b squared minus c squared divided by 2ab. Right? In a very similar fashion to the way this was. Right? You could do the same setup. Right? And then angle C would be the inverse cosine of, 11 squared plus 26 squared minus 20 squared divided by 2 times 11 times 26. Alright, and I'll put this in. Alright, so we got inverse cosine of, and then parentheses around the numerator, right? 11 squared, and that's 121, plus 26 squared minus 20 squared is just 400. Close parentheses on the numerator, divided by, and then parentheses for the denominator, 2 times 11 times 26. Close parentheses on the denominator, close parentheses on the whole thing. About 46 degrees. Because that rounded to 1 decimal place is just 46. So angle C is approximately 46.0 degrees. And you could do the same for angle A if you wanted. It's just, now I have two angles, so I can find the third one easily by just subtracting those from 180, right? So let's do that here. Angle 110.6 plus 4. This is 156.6. Right? These two angles make 156.6. So what's left over to make 180? Right, that'd be 23.4 degrees. 156. If you add these up, that's 69.4 plus 10.6 would be 80 plus 100. That's 180 degrees. So 23.4 degrees for A, 46 degrees for C, and 110.6 degrees for B. And make sure these match. It's 23. All right, so they were a little. I guess I'm a little off, but whatever. 23.3 for A, 46.1 for C, because they probably used the law of sines or whatever and used some rounded values. They must have used a rounded value somewhere. So I'm assuming they used the law of sines, because you can. I mean, once you find that largest angle, you could use the law of sines to find the other two angles if you want. So yes, this one here though, right? 110.6 degrees for B, 23.3. We said 23.4 for A, and 46.1 or 46.0 for C. And yeah, I'm assuming they used the law of sines. Yeah, look, see, they did. And you see how they use the rounded version of angle B. And because they used these rounded versions of things, they were a little off of what I had. What I had is more accurate than what they have. All right, but still ends up fine. Basically the same number. Okay, so there. So again, hopefully, after these couple videos now, you know how to find missing angles in a side-side-side triangle. And hopefully watching me do it, looking at more instruction when you need to, and reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you work on this on your own. And thank you for watching.